Hello, student. Uh, in this lecture, I will discuss what is conformal mapping. So, before discussing conformal mapping, you must know what is mapping. So, by the end of this section, you will learn what is mapping and what is conformal mapping. So, mapping is nothing. Mapping, you can say transformation also. So, when a function from domain D to D star, okay, D is what? D is actually D contains all the point which lies in Z plane. Okay. And D star contains all the point which can consider in W plane. So there are two planes actually. One is Z plane and second is W plane. Such that W0 is equal to f of Z naught. It means that whenever Z naught point lies on a function, it will give W naught point. Okay. Suppose this is a curve in W plane, Z plane, sorry, and this is image in W plane. So whenever the points which contains in the Z plane maps with W plane, it is called mapping. Okay. So mapping is what? Mapping is nothing but it converts or you can say transform the point from Z plane to a new plane called W plane. Okay. So this function is defined in a region D of the Z plane. And what does actually mapping means? You can say for all points, let's suppose this is point which belongs to D and this is point belongs to D star such that f of Z naught is equal to W naught. Okay. So for any point Z naught in the Z plane, there is a corresponding point W naught which is equal to f of Z naught in W plane. Okay. So this is the basic definition of mapping. So mapping is nothing when a function maps from domain D to domain D star, you will get an image. Simply you can say image of Z naught is W naught. So image of Z naught is what? W naught. And both these are the points. First point lies in Z plane and second point lies in W plane. Now we will see what is 1-1 mapping. 1-1 mapping. What is 1-1 mapping? Okay. If every point P in the Z plane gives us a unique point Q in the W plane, and no two points in Z plane give the same point in W plane, then we say the function is 1-1. Okay. So I will explain this. Every point P in Z plane, G plane means original plane, gives us a unique point Q in W plane. Okay. Such that no two points in Z plane give the same point W plane. Okay. Then we can say the function is 1, 1. Okay. Then we say the function is 1, 1. Okay. Now we understand what is angle preservation. Okay. What is angle preservation? If two curves, let's suppose curve is C1 and C2, meet at, let two curve C1 and C2 meet at an angle alpha. Alpha is what? Angle between the two curves at a point Z0. Okay, then their image, then their images C1 star and C2 star. In W plane should also meet, at same angle alpha. Okay, W is equal to F of Z0. Okay, so I tell you again, suppose this is Z plane and this is W plane. W plane is called image of Z plane. Let's suppose there are two curves C1 and C2 and these curve meet at angle alpha. This is angle alpha. Then their corresponding image C1 star and C2 star. C1 star and C2 star are the image of C1 and C2 and their angle between these two curve is also alpha. Then you can say the angle is preserved. Okay. If the angle is preserved and the function is 1, 1, then you can say this is what? Conformal mapping. So if I ask you what is conformal mapping, you can say that a mapping or a transformation which satisfy these two conditions. What are the conditions? It is 1, 1 function and angle is preserved. What is angle preservation? If two curve meet at angle alpha, then their images should also meet at their angle alpha. If these two conditions satisfied, then you can say this is a conformal mapping. Okay. So this is conformal mapping on the basis of curve. Further, I will tell you what is conformal mapping with the help of bilinear transformation in the later section. Okay.